Hey guys, welcome to Afaq Ahmad Coaching Academy, and today we are going to discuss how to find the tension in a circular motion. So we can find tension in a circular motion by considering two types of circle. The first one in which the body moves in a horizontal circle, that is horizontal circle, and the second one is vertical circle. So I will prefer definitely to the vertical circle because this is one of the most important for the entry test level. I mean to say Mdcat, Etea, or any kind of stuffs you are gaming this year. So this one is most important because it has a little bit logic as compared to this one, because in this case we will have a different tension. Sometimes we will have a maximum, sometimes have a minimum. At midpoint that will be different. So this one we will discuss later, and first of all we will discuss this one. So consider a horizontal circle, that is horizontal circle, and here it's the center of the circle, and here is a string, and with the string a body attached with the mass m. Okay, so here the tension is toward the center of the circle. Now what does this tension does? That makes it more interesting. Here the tension just simply provide the centripetal force, means that centripetal force is provided by this tension. And if we look at dynamically, so there's I mean to say there's a fair, because the units of the tension is also Newton and the unit of the centripetal force is also Newton. So Newtons means that both quantities are dimensionally same. I mean to say dimensionally are same. So this makes a little bit sense. Okay, so if the gravity acts downward, so I would write G. So this means that the weight of this object acts downward because the gravity acts downwards. Okay, but the circle is not like this. Consider this is a circle. So this circle is not like this. Basically this circle is like this. Okay, so it means that the circle is like this. You can see that the body will move like this. It's not will move like this. Okay, so here the centripetal force compels this body to move in a circle of the radius r with a velocity v. So I can write it here that the tension is equal to mv square over r. So that is one of the most important result I got. So we can write here that the tension in a horizontal circle, will always equal to the centripetal force. Wow, that's one of the most important result. I will label by star because this one is important for the MCQs. I will prefer for Mdcat because in that case you will have a little easy MCQs as compared to the Etea. Okay, the next point which I'm going to discuss, that is very important. So here if we consider the mass and the radius of the circle constant, so I can write the equation. I would like with a green one to differentiate it from this one, that is T is directly proportional to the v square, means that we have like T1 or T2 is equal to V1 or V2 whole square. And here this makes it more interesting. We have got another equation, and the second one I can also write that V1 over V2 is equal to T1 over T2 whole under. Wow, there's another equation I got. So all these equations that I have written with the green are important for the NUST, and this one is important for Mdcat, and also this one is also important for the Mdcat. I would like that the whole mess I did here is important for the Mdcat. Now what is the next one? The next one is very important, that is horizontal circle, that is vertical circle. And vertical circle, you know, the velocity as well as the tension will be different. Here we are considering a vertical circle by a green. Okay, so that's a vertical circle. Okay, that's the center of the circle. Here we have a body. First of all, the body was here at the point A, and then the body moved here to the point B, and it lost the body was at the point C. Okay, So in this case, the gravity also acts downward. The gravity also acts downwards, means that the motion of the body and the gravity of the body are acting parallel to each other. When the body moves downward, so that the gravity and the motion of the body, means velocity, are both having angle theta or phi. I will write here that is 0 degree. But if the body moves upward and the gravity downward, it means body move upward, velocity is upward, and the gravity is downward. The gravity is downward. So in this case, the angle theta will be 180 degree. Okay, so this was this was not so important. The most important is I have to derive the derivation of the equation. That is important. So at what point the tension will be maximum. Okay, so in order to find the tension at the point A, we know that the tension is equal to these are attached to the strings, and of course here the tension is also attached to the center of the circle. Tension is also attached to the center of the, in all cases the tension acts to the center of the circle. And this tension, what does this tension does? This provides the centripetal force. So here the tension is equal to mv square over r. So do you think this equation is complete? No, not at all. This equation isn't complete until we put here mg. Wow, this is the most important result I got here. Now the tension is equal to mv square over r plus mg. Why I put here mg? So that's the most important. Now at the point A, you know that the tension acts upward. The tension acts upward and the gravity acts downward. The gravity acts downward, and the angle theta between them 180 degree. So you would think why I heard a positive sign, because the tension and the gravity are in opposite sense, means that the tension and the weight of the object are in opposite directions. So I have to put here negative sign, but it isn't like the vectors, because here I have to put positive signs. What really a tension is? First of all, you have to know what really a tension is. So tension is basically a tightness. For example, we have a body here. So if we have a body of 1 kg, so tension will be T1. But if I put attach a body of 2 kg, now a body attached of 2 kg, so here the tension increases, means that T2 is greater than T1. That's related to the T2. Tension acts upwards and the gravity acts downward, means weight of the object acts downward. So that make the string more tight. That make the strings more tight. As a result, the tension will increase at the point A, but at the point B the tension will be different. What will be the tension at a point B? So that is T is equal to mv square over r. Here we have to neglect the mass of the object, because the gravity acts downward, and the means that mg weight acts downward at the point B, and the velocity is acts upward. So we will know that here the tension will be minimum from the point A and will be greater than the point Z. So this makes it most important. So we have to neglect here the weight of the object. Okay, now how to find the tension at the point C? So tension at the point C is equal to the centripetal force, that is mv square over r, minus that is the weight of the body, that is mg. So that is the equation for the for the tension at the point C. Okay, now the question arises why I put here the negative sign. So that's because here the gravity is also acts downward, and the the tension also acts downward. Of course, the mg mass there, so see the weight of the object is also acts downward due to the gravity. So as a result, these effects makes these strings to just compress, because this strings wants to compress, because all these things are parallel to each other. So here the string just want to compress, and as a whole body comes toward the center of the circle. So these terminologies, these effects makes this string, in this string the tension smaller as compared to the tension that was at the point A. So that's why due to this decrease in the tension in the strings, I put here the negative sign here. So this equation is for when the body was at the point A, this equation was when the body was at the point B, and this equation was when the body was at the point C. So now finally we can say here, we can write here that the tension at the point A will be maximum, because here the positive signs of the centripetal force and the weight of the object, and tension at the top of the circle will be minimum. So at the bottom, due to this negative sign, and at the mid the tension will be smaller than the point A and will be greater than the point C. So we can write here the tension at the point A is greater than the tension at the point B, and the tension at the point B is greater than the tension at the point C. So this is one of the most important results, and this is basically what I wanted to show you in this video lecture. So I would like that this one, if you got this equation, if you get this equation somehow by practicing it or by just looking deep into it, so you can learn all the related stuff. So we can again say that the tension at the bottom will be maximum and the tension at the top of the vertical circle will be minimum, and at the point B the tension will be equal to that of the horizontal circle, because at the point B you have to consider just T is equal to mv square, and that was which we derived in case of the horizontal circle. So the tension in the horizontal circle will be equal to the tension in the vertical circle if the body is at the mid point. So this is also one of the most important point. So I hope you like the video. For more video, please subscribe to our channel. Thank you very much. Have a good time.